Two blocks of masses 2 kg and 1 kg respectively are tied to the ends of a string which passes over a light frictionless pulley as shown in the figure below. The masses are held at rest, same horizontal level, then released. The distance traversed by the center of mass in 2 seconds is dash meter. So as we can see here, a pulley which is connected with a rigid support. Okay, and there have two masses 2 kg and 1 kg. They are attached to a string, and there have some assumption, that is the string is light, the string which passes over a light frictionless pulley. So that means we don't need to measure or don't need to take account of the mass of the pulley. And also we can assume that the string is inextensible. That means the tension which is applied on the string T will be equals to the same in both cases, that is T. Now we will see what will happen when they are released from their equilibrium position, or you can say from this position. When they released, then what will happen? As we can see that 2 kg mass is more weight than the 1 kg mass, then in a generally or in naturally we can say that the 2 kg mass will be fall downwards and 1 kg mass will be going in upward due to the more weight of 2 kg mass. Here we can take, say, M1 is the mass and M2 is the mass which are attached to the pulley. Now here M1 mass is greater than M2 mass. As you can see that M1 equals to 2 kg and M2 equals to 1 kg. Now since the string is inextensible, so we can assume that the tension T here and the tension T here will be same, right? And if you want to draw the free body diagram, then we can say that the mass m2g will be in downward direction. As we know, the gravitational force or weight always in downward direction. Similarly, it will be in downward direction for mass m1. So if you want to write the equation of motion according to Newton's second law, we can say that m2g is less than tension T. That's why it is going in upward direction. Therefore, we can say that tension T minus m2g, this force or this unbalanced force is responsible to shift the mass m2g in upward direction with, say, acceleration a. Since the string is inextensible and the pulley is frictionless, then we can assume that the acceleration responsible for a mass m2 to go in upward direction, the same acceleration is responsible for mass m1 which is going in downward direction. So therefore we can write m2a. Similarly, we can write for mass m1g equals to m1 into a. So by solving this, we can calculate the value of a. Let's see how can we calculate. So say equation 1, equation 2. If we add equation 1 and 2, let's add equation 1 and 2, then we will have m1g minus m2g, since t tension will be cancelled out, equals to m1 plus m2 into a. Or we can write acceleration a equals to m1 minus m2 by m1 plus m2 into g. So this acceleration is belongs to the individual acceleration of mass m1 and m2. But here the question is given for the center of mass. What do you mean by center of mass? As we know, center of mass is a single point of a system which is acted, or where we can assume that the whole mass of the system is supposed to be concentrated. Or in a simple way, if you want to say you that if in a irregular system, if this system is moving along a particular direction, then if you want to write that how or in which direction or which mass we should take into account to write the equation of motion clearly, then we can assume one point as a center of mass, by which, or by doing this, if the single point is moving along a direction, it defines that the whole mass of the system is concentrated at this point, and if this mass is going along this direction, the same characteristics will be showing by the whole system is moving along a particular direction. So that means we can easily say that the center of mass for a 2 kg and 1 kg body, since the 2 kg is moving in downward direction, since it is not a homogeneous or the masses are not same, then obviously the center of mass will be shifting towards the more mass of the system. So since the 2 kg is moving downwards and 1 kg is moving upwards, then by seeing this, we can say that center of mass of this whole system is supposed to be going in downward direction. So let's see it will, how can we write this? So now we want to calculate the acceleration for each and individual particle m1, m2, then what will be the acceleration value? Let's see. So m1 equals to 2. So 2 minus 1 by 2 plus 1, and the value of g that is given to the question, it will be 10 meter per second square. So it will be equals to plus 10 by 3 meter per second square. So that means this acceleration is responsible for mass m1 to go upwards, and the same acceleration is responsible for mass 2 kg to go downwards. So we want to calculate the center of mass because the question is based on the center of mass, not based on the individual acceleration. So as we know, the center of mass, the center of acceleration can be written for the two masses of a system. Let's say m1 a1 plus m2 a2 by m1 plus m2. Now here the mass m1, which is nothing but 2 kg. So 2 into, now here we can see the acceleration is plus 10 by 3 meter per second square. As you know, the acceleration is a vector quantity. So if you consider the acceleration is positive for upward direction, then acceleration will be negative downward direction. So if we assume this, and we can see that 2 kg mass is going downward direction, then we can simply put minus 10 by 3 plus m1 done. So m2 is for 1 kg. So 1 into, since m1 is m2 is going upwards, so it will be plus 10 by 3 by m1 plus m2, which will be 2 plus 1. Let's see what will be coming. So as you can see, if we take a common of 10 by 3 from both sides, then it will be minus 10, 2 plus 1, 3, 3, 3 multiply minus 10 by 9 meter per second square. So that means we can say the center of acceleration, or the acceleration due to the center of mass, the value is minus 10 by 9 meter per second square, and the minus sign now signifies that the object or the whole system is moving towards the 2 kg. That's why the center of acceleration OCM will be going in downward direction. So now we can see the distance traversed by the center of mass. Then we can easily write the equation of motion that we know. SCOM equals to U COM plus, basically S equals to UT plus half AT square. Here all the quantity will be replaced by the center of mass because the question is about regarding the center of mass. So SCOM, center of mass, equals to, initially the masses are at rest. So at rest means we can assume that acceleration or the initial velocity at this case is 0. So then obviously the center of mass will also be 0 because it is not moving, because this only depends on the velocities or speeds of the other particles. 0 plus half center of mass, the value, if we write minus, then it will show us the direction in the downward direction. You can also write plus, then you need to mention that it is in downward direction. So let's write the numerical value. So minus 10 by 9 into t square. T is given as a 2 second, then we can write as a 2 square equals to, if we calculate, then we have minus 20 by 9 meter, and which will be nearly equals to minus 2.22 meter. So that means option number 3 is right. Thank you.